Welcome, guys, for this class. Uh, During previous class, we have studied about addition of forces. We have seen what will happen if all the forces are acting along the same direction, or if the forces are acting along different direction, how these vectors are added. And we have also learned about addition of vectors by head and tail rule. Then we moved up to trigonometric ratios, and during trigonometric ratios, we have discussed three types of the ratios which are mainly used. And at the end, we have seen how to calculate what are the main values of these angles with the help of a chart. So here it is. Now we are starting new class, that is resolution of forces and vectors. Because force is also a vector, we have to resolve some vectors into its component. Then we will see what the components are. These components are also playing very much important role in engineering and other branches as well. During higher classes, you will go up to detail to find out the resultant of forces of the vectors. So here it is. The process in which one vector is decomposes to two or more than two vectors. Decomposes splits up. The vectors obtained are called component of original vector. We will see with the help of diagram. For example, if the F force is acting along or between x and y axis, xy plane or xy plane, if we draw a normal on x axis and also y axis such that this is the example how it is done. If you look at this figure, the diagram, you look at this is basically x-axis and this one is basically y-axis. A force is making an angle between x and y. This force is called F force. We will draw perpendicular from this point on x-axis, and similarly we will draw a line from y on y-axis. If you have drawn it, then this component along x-axis is called basically x component of the force. It is written as Fx. This component is Fx, and this component along the direction of y is Fy component. So what we have done, we have resolved, we have uh, splitted this force. We have resolved this force into its component. One is called vertical component along the direction of the y. The other one is called the vertical component, horizontal component in the direction of the x. So these are two components. One in the direction of y, vertical; other in the direction of x, horizontal component of the force. So here it is. We know from the trigonometric that sine theta that is equal to Fy divided by Fx, perpendicular divided by hypotenuse. So perpendicular is Fy, hypotenuse is F. So Fy, the vertical component of the force, is Fy is equal to F sine theta. So this is the vertical component of the force. So for cosine theta, it is Fx divided by F. What about Fx? It is base. What about F? It is hypotenuse. Base divided by hypotenuse, that is cosine theta. So what about the horizontal or Fx component? This Fx component is equal to F cos theta. So these are the two components of this force. You have resolved F force into its horizontal, this one, and into its vertical, this one component. So these are the component of force F. This one is vertical component you have calculated by using trigonometric ratio, and this one is horizontal component. You have calculated this component again by using trigonometric ratio, and it is Fx is equal to F cos theta. Suppose you are given a problem. Problem is that a force of 20 Newton makes an angle of 30 degree along x-axis. Force of this one, this one. A force of 20 Newton is acting along x-axis and it makes an angle of 30 degree. You will place the value of angle here, 30 degree. Then find the horizontal and vertical component. For vertical component, you will multiply 20 Newton force with the value of sine 30. And similar is the case for horizontal component, but here you are using cosine theta, 20 Newton force and with an angle cos 30, You will multiply these two, then you will be getting horizontal component by using cosine theta, and here you will be getting vertical component of the force. So the resolution of force into its component. So here it is. Subtracting, and if you are asked to find out the magnitudes of these two forces, then this is the formula used to calculate Fx square plus Fy square, that is equal to Fx F square cos square theta plus F square sin square theta. You will take the common from this trigonometry ratio, you will be getting cos square plus sin square theta, then it is 1. So this is the technique through which you calculate. You use this formula in mathematics and so many times, and you will be asked that cos square theta plus sin square theta, that is equal to 1. How it becomes 1? This is the reason that it becomes 1. And then you put the values. Finally, you're getting fx square plus fy square, that is f square. Where this has gone, because this cos square theta plus sin square theta is equal to 1. So you have placed here 1. So this F magnitude of this resultant force is calculated by using this formula. And this formula is F is equal to F square x plus F square y. If you are given a horizontal component of the force, say that is 30 Newton, and then you are given that the vertical component of the force is 25 Newton, then you are asked to calculate the resultant force, then you will use this formula. You will put the value of horizontal component, then you will put the value of vertical component, you will take the square root, and finally you will be able to calculate the magnitude of that resultant force. So how will you find the direction of that resultant force? The direction of resultant force is calculated by using this formula. Horizontal component base divided by perpendicular. So it is equal to tangent theta, tan theta. Theta is calculated by taking the inverse of tangent theta, and then you will be able to calculate the direction of that force. Suppose again the direction along horizontal is 25, along vertical say it is 30, then Newton, then you will find the ratio of these two forces, and finally you will take the inverse of tangent theta. Then you will find the direction of that angle. Yes, what are the rectangular component? This is the force F, and you have resolved this force into its vertical and horizontal component. Then what's the rectangular component? The component of a vector which are mutually perpendicular to each other are called rectangular component. This basically fx and fy, fy and fx are mutually perpendicular on each other. So that's why mutually perpendicular uh, components are called a rectangular component of the vectors. This one is y component, this one is x component. So they are mutually perpendicular to each other. So these are called rectangular components. So the rectangular component of the force are fx is equal to f cos theta and fy is equal to f sine theta, which we have already done. Basically, this is the horizontal component and this one is the vertical component. These two are perpendicular, mutually perpendicular to each other. So that's why they are called rectangular components. So with this, our class ends. We will start new lecture by tomorrow. So let's come back and revise the main topics of this class. Here we were at the end. These are the mutually perpendicular two components and these are called rectangular components. Then before this, what we have done, we have studied about rectangular components. These are mutually perpendicular one to each other. And before this, we have covered, that is the direction of a force. From where you have to calculate the direction. Let's start from where you have done the resultant force, magnitude of the resultant force by adding the components of these two forces together, Fx and Fy. These two are perpendicular to each other, so that's why they are called rectangular component. Then how will you calculate the direction of this force F? You have used the ratio, you have used the trigonometric ratio, that is tangent theta, that is Fy divided by Fx. You will divide the horizontal component of the force with the vertical component of the force, and then you will take the inverse of tangent theta, and you will be calculating the direction of that force. If its angle is 45 degree, of course, it is exactly in between F and Y axis. So angle shows the direction of a force. Then from the starting, we have done trigonometric ratios to calculate the horizontal and vertical component of the force. This force is F force. It is making some angle with the horizontal, and perpendicular is drawn from any point that is from head of this vector on x-axis, and then we have joined with the origin. This is horizontal, this one is vertical component, and by this we have completed a resolution of forces, a resolution of the vector. So with this, our class ends. I hope you people have enjoyed. Thank you very much for your patience. Hope you have